Hi everyone, let's start solving today's LeetCode daily challenge question 1498. Number of subsequence that satisfy the given sum condition. Okay, let's straight jump to the question. You are given an array of integer nums and an integer target. Return the number of known empty subsequences of nums such that the sum of the minimum and maximum element on it is less or equal to target. Okay, and the answer can be too large, so we need to return it with the modulo of 10 raised to power 9 plus 7. Okay, so let's try to understand the question with an example. Okay, so 3 5 6 7 is given to us and the target value is 9. Okay, so we need to find the subsequences. So as 3 can be one of the subsequence, 3 5 and 3 5 6 3 6 3 5 6 7 can be a subsequence, and 3 6 7 can be a possible subsequence. Okay, and there can be many more. Okay, and using 5 6 and 7, but why I written this much? So let's say like 3 here in this subsequence, 3 is the minimum and 3 is the maximum, and if I add it up, so it will give me 6, which is less than equal to 9. 5 and 3 plus 5 is 8, which is less than equal to 9. 3 5 and 6, where the minimum is 3 and maximum is 6, so 3 plus 6 is equal to 9, which is less than equal to 9. The same is 3 plus 6 is equal to 9, less than equal to 9. But here I can see 3 5 6 7, where minimum is 3 and maximum is 7, so 3 plus 7 is equal to 10, which is not less than equal to 9, so this is not a valid one. Same with this one, 3 6 7. So basically I have 1 2 3 and 4. Okay, so basically these are the valid subsequences, so the answer of this example is 4. Okay, so the brute force, what will be the brute force way to solve this question? So the brute force way is nothing but to generate all the subsequences and iterate them and find minimum and maximum from the subsequences and uh, check if they are valid or not. And from that we can generate the answer. Okay, but now how we can optimally solve this? So let's try to see one more approach. Somehow we can see the array. So what we need to see the minimum element and the maximum element. So this is the min thing we have to find out, and this is the maximum element we need to find out from an array. So, and we need to add both the elements of the array. So we need to take somehow, if we sort the array, if we take a sorted array, so 3 3 6 and 8, if we take a sorted array, and here I can see from the left hand side I will always get the smallest element, and from the right hand side I always will be getting the maximum element from the array. Now why I can use sorting? Because in this question I do not have to consider the position of the elements, rather than just focusing on the magnitude of the elements, like uh, the minimum or maximum element is part of my subsequence or not. That's why the position is not more important is in this question. So we can use sorting in this question. Okay, so now let's say the target is 10 in this example, and if I take a left pointer and right pointer, so this is my search space. Now if the minimum is 3 and the maximum is 8, all the elements between this can make a part of the subsequence. So in that case, how many what will be the count of the subsequence? Okay, so but before jumping to the count part, we need to see the algorithm, like how we can shift our search space, like left pointer and the right pointer. So what we will do, we will check the valid, if the subsequence is valid or not. So what condition we need to check? So we'll take the left pointer value plus the right pointer value. If that is less than equal to 10, or the, I can say, the target value, in that case I can say that is my valid, and I can generate the subsequences using that number of elements which are part in this search space from left to right. But as in this case 3 plus 8 is greater than 10 and the sum is 11, so how I can reduce the uh, my search space now? So using the binary search concept, I can reduce the right pointer to towards left. So 3, 3, 6, 8, and now my left pointer will not change, but right pointer will be pointing at uh, towards the left. Okay, so I shifted my right pointer. Now if I check the valid condition, so minimum is 3 and the maximum will be coming from the right pointer. So 3 plus 6 is 9, and which is less than equal to 10. Okay, so in this case I can generate subsequences. Now let's say the, okay, so this is our first condition to check the sub array is valid or not. Here I am focusing on the sub array because from the left or right pointer we got the sub array is valid or not. Now from the sub array we need to pull the count. So how many subsequences can be generated from left to R? So as we all know, to generate the how many subsequence can be generated from an array is nothing but 2 raised to power n, where n is equal to e minus s plus 1. Why we are doing plus 1? Because the array is 0 indexed. Okay, so e is the right pointer in this example, and this is the left pointer, and 1 is due to 0 index array. Okay, now as per the quotient condition, the subsequence cannot be empty, but this 2 raised to power n will provide me those subsequence as well where there is no element present in. So this 2 raised to power n include that particular subsequence as well. So as per condition, non-empty subsequence only I have to include. So for that, what will be my new formula? So what I can do, I will always include the left position element in my subsequence always. So for that, now the I will use the same 2 raised to power n, but now n will be become my e minus s plus 1 plus 1. Here s plus 1 stands for like if 3 is my the leftmost element, I will be start generating the subsequences from left plus 1. So left always be a part, the leftmost element always be a part of my subsequence, so the subsequence will never be empty. And if I open this up, so e minus s minus 1 plus 1, here 1 and 1 will cancel out, so n will become e minus s. Okay, so if I use this concept, so first I will do sorting, then I am applying 2 pointers, and I am reducing my search space using the validation condition, reduce search space. Okay, and the fourth thing is I need to, for every valid for every valid subarray I need to compute 2 raised to power n. For that, like generate count of subsequence for every valid subarray. But okay, so this will take order of n log of n 2 pointers. This whole thing is order of n, but for every single element, for every element, if we use the inbuilt, so for every single sub array we have to calculate the power of 2 for that particular n, so that will give us TLE. So to resolve that part, resolve TLE, what we will do, we will pre-compute 2 raised to power till the input array size. Input array size. This thing we will pre-compute and we'll use this to compute the count of subsequences. So I think the algorithm is pretty much clear. So let's jump to the code and we'll see the step-by-step process. Okay. So this is the code base, and so as the question is suggested, we have the answer can be large. So we initialized a mode value, and as I written here as well, I will pre-compute the power of 2. So I will store all the values of power of 2 in a array. So I name the array is power of 2, and so 2 raised to power 0 will be 1 only. So from 1 I will be start iterating, and till where I need to compute the power of 2 is nums dot length only. So here I computed all the power of 2 till nums dot length, so I can use in my 2 pointers approach. Now after that I sorted the array and I initializes my left and right pointer, and the count initially is 0. Okay, and here I written all the things which we discussed above, and if nums of left and nums of right, here we are doing just L plus R, checking the valid condition. If it is less than target, then the sub array is valid. Now from the valid sub array we can count the number of subsequences generated. So count is nothing but the previous count plus power of 2 R minus L. This R minus L is nothing but R minus L plus 1 plus 1, which we discussed above. So if I open this, so L minus 1 plus 1, we just cut it out at the end, it will become R minus L. And to for the overflow condition, I mod it with the mode value, which we made it above constant. Okay, and if it is valid, then I generated and counted the subsequence from that subarray, and to reduce the search space I did left plus plus. And if the array is not valid, if the sum of left and right element is greater than the target, so I need to reduce the search space. So for that I am doing right pointer minus minus, and after computing all of this I am returning the count value. So now the overall time complexity to compute this, this is order of n, and this is also order of n, but sorting takes in the worst case order of n log n. So the overall time complexity will become order of n log n, and the space complexity, as we are storing all the power of 2 in an array which will be of size n, so the space complexity will be of order of n. So, and after I submitted, so I got 100% results from it, so it beats 100%. Okay, so I will share this particular code as well into the description as well. So if this video helped you to solve this particular question, so you can like this particular video and subscribe to my channel. Thank you so much.